Hi, welcome to question 4 of the Leave Insert Ordinary Level Paper 1 in 2021. If you want to copy the notes I'm working off, just send me an email to shanetroy@gmail.com. And if you like these videos, just hit the subscribe button to get access to more playlists. Okay, so I've gone back a page. So in question 4 here, we're looking at, it looks like algebra, and it says here, solve the equation, and it gives you this long list of things. And it says where x is an element of R. Now, all that means at the end there, if it's an R, it means it's a real number, which basically is any number. Okay, just to keep it simple. It says then solve. Now, you can only solve an equation of one unknown. So if I look along here, is there more than one letter? There's an X. No, and there's an X here. So this is an equation of one unknown, and therefore it is solvable. If there was two unknowns, it wouldn't be solvable. Now, they wouldn't be asking that without it being, with there being some other information. But in this case, there's no trick here. This is straightforward algebra, and that's what they're testing. Can you simplify this down to find out what x is? Like, I don't know if it's a fraction, a decimal, whole number. I don't know what it is. Okay, it's any number. I can't guess it because it could again be any number. So if I could guess it, I could find. Let's say x was 2. If I put 2 in everywhere I see x, okay, in brackets, and then simplify it out, literally put it to the calculator, does my left side equal my right side? If it does, I have the correct solution. Now, this has been kind of asked on question 3 of this paper, so it's coming up again. Now, we don't know what x is, so we have to try use algebra to find out what it is. There's 10 marks going here. If I can do something relevant to solve this, I'll be on the 3. If you ever see an equation or something like this, you're absolutely stuck on what to do. Remove brackets. Brackets mean multiply. So let's go left to right. 4 times 2x is the same thing as 8x. 4 times 2 apples is 8 apples. Okay, so that's that bit done. Then 4 times 3 is 12. Now the minus 7 doesn't change, at least not yet. Nothing's multiplying by it. So the left side, I've removed the brackets. Now on the right hand side, if I remove the brackets again by multiplication, 3 times x is 3x. And then 3 times negative 5 plus by minus is minus, 3 5s is 15. Now at this stage, if I look back and I go, okay, I've got the 3 marks. There's money in the bank. At this stage then, I want to try to get to the 7. Now again, I want, when I'm solving something, I want the unknowns on one side. Okay, so in this case, the x. I want the x's on one side, everything else the far side. Now, the first thing I see I can do there is, I can do a bit of simplification here by adding or subtracting. 12 takes 7, which is 5. That's all I'm doing. Okay, so it's a little bit simpler. And I'm looking then, okay, I want the x's to be on one side. Now, just as an extra tip, I want the x's to be positive if possible. It'll just make things easier on the flip. Now, the 3x here, if I want to get rid of that, this is the core of algebra. If you are not sure of your algebra, keep it simple, do one thing at a time. Look at what do I want to achieve? And I want x equals a number. Now, if I want x equals a number, the x's must be on the same side. The simplest way to get rid of this 3x here, it's not on the right side. I want to get rid of it, so I take it away. If I do that to one side, I must do it to the other. Now what's going to happen here is going to give me 8x take away 3x is what's actually happening. Now with the 5, nothing's happening to that. On the other side, this is 3x take away 3x. Now if I have €3 and you take €3 off me, I have no euro. They're gone. And I'm left with the negative 15. What's the consequence of that? Well, your x's are on one side, so you've gotten a little bit further along. Let's go left to right again now and go, can I do anything? Can I simplify? 8 of something, take away 3 of something is 5 of something. 8x take away 3x is 5x. So yeah, I'm simpler. Now if you see what's happening here, okay, I want the numbers to be on the other side. So the simplest way, or the algebraic way of doing that is, if I have a 5 here and I want to get rid of it, take 5 away from it. I'm allowed to do that as long as I do it to both sides. Now what's the consequence of that? Okay, so 5x doesn't change. There's nothing to change it. If we go left to right, 5x stays the way it is. 5 take away 5, well, that's gone. Okay, and then the far side, minus 15 take away 5 is the same thing as minus 20. Now, you can probably see the answer at this stage, but I want to get rid of this 5. Now, one way to do that is to divide it by itself. Any number divided by itself always turns into 1. Okay. Now, if I do that to one side, I have to do it to the other. Now, what's the consequence of that? 5 divided by 5 gives you 1. So 1x is equal to minus divided by plus is a minus. 20 divided by 5 is 4. Am I there? Well, I found x is equal to a number, negative 4. Now, if negative 4 was right, okay, if I put negative 4 in here instead of x, okay, now, probably a bit messy to do it here, minus 4. Actually, let me rewrite it. 4 times 2 by minus 4 plus 3, supposed to be a 3, minus 7. Is that equal to 3 times minus 4 minus 5? Now let's work on the left-hand side. Okay, I could program that in the calculator, but if I do inside the brackets, so 2 times negative 4 is negative 8. Okay, let's keep doing inside the brackets. Okay, it's 4 times negative 8 plus 3 is negative 5. Do your multiplication next. Plus by minus is minus. 4 5s is a 20. Take away the 7. Finally, do the addition subtraction. So that's minus 27. Now, is that equal to, on the far side here, do inside the brackets, 3 times minus 4 minus 5 is minus 9. Keep going. Plus by minus is minus. 3 9s is 27. Now, that's not going to change. What I'm basically asking, is minus 27 equal to minus 27? It is, because x is equal to minus 4. If I put any other number in there, it wouldn't have gotten left side equals right side. So we know we have the right answer. Now, we're not being asked to do this whole bit here. Okay, I'm testing the answer just to see if I'm right, but I don't need to. If I'm happy enough that my answer here is right, keep going. But if you get and do this for yourself, you know, leaving this question, you have the 10. Okay, push on. Now, if I remember here, question 4, I suppose that's the answer done out digitally. And again, if you want the copy notes I'm working off, just drop me an email at shanetroy@gmail.com and I'll send on the marking schemes, exam papers, and the notes here. So part 4, part B. Now, if you notice up here, this is a D scale, so a breakdown of 5 grades, but it's worth 20 marks. It's a humongous amount of marks, okay, for the exam. And part B says solve the simultaneous equations, and it gives you 2 here. Now, just as context, that's the equation of a line, so it's a linear equation. Okay. This is the equation of a circle. Now, I know that because x squared plus y squared is classic. And this is a circle with center 0, 0. Now, just for context, this next bit isn't needed for the question, but just to give some background. The linear equation there was 2x take y equals 7. So it's an equation of 2 unknowns, and the biggest power is 1 on the x. So that's linear. Now, I've drawn this here. Okay, you can see that it's crossing the y-axis at 7, actually negative 7, and it's got a positive slope. It's going up. Now, the other equation gives you the equation of a circle. Now, I know this has radius of 7. I know that from the equation itself, which is 49, but whatever, we won't go down the road too far. It's got an equation of x squared plus y squared with no numbers attached to it, so it has center 0, 0. So it looks something like that, and there's the 2 lines. Now, ultimately, what they're asking here is to find these 2 points, the 2 points of intersection. So this is a classic question. Now, they're not phrasing it they're just phrasing it from an algebraic point of view. But this could come up in coordinate geometry, where they give you the equation of a circle, they give you the equation of a line, and they ask you what are the 2 points of intersection. Or it might ask you to prove, is this a tangent to the curve? Now, this is not a tangent. This line, okay, crosses at 2 points, so it's not a tangent. A tangent crosses a circle at 1 point only. So this is a chord, okay, and we can see there is roughly, this is 4, 5, 6, so it's 5.5 on the x, a little bit over 4 on the y, and down here, now it's actually on the y-axis, so this is actually 0, negative 7. Now, we will see if we get those two answers from actually manipulating the work. Now, with an equation or simultaneous equation, there's just two methods. One's the elimination method, okay, but this is actually the substitution method is what would work here, okay. This is a skill that you kind of have to know. Now, you may not be just be coming in on question 4 on its own, but literally question 3 just done simultaneous equations again, okay. So without this, you'd have lost out on 30 marks. The 20 from here, and there's 10 in the last part, question 3. With the substitution method, I want to take the easier equation. So if I number these equations 1 and 2, I want to take equation 1, okay, so 2x minus y equals 7. And I want to manipulate that for one of the unknowns, okay. So I'm not going to be able to solve this. This is two unknowns, but if I rearrange it so it's in terms of one of the unknowns, it's going to be useful. We'll see why in a second. Now, with this particular case, it's probably better to do this for the y. If I do it for the x, I'm going to end up with a fraction. I don't like fractions, so let's keep away from that. And this way, I want y to be positive, okay, and I want it on the far side. Now, I'm going to leave this where it is. I'm actually going to move the 2x to the far side. Now, one simple way to do that would be to take 2x away from it. Do it to one side, must do it to both. What's the consequence? Well, they cancel. You're left with minus y is equal to, usually we put the x first, minus 2x plus 7. Now, that's not what I want, because I want this to be positive. The simplest way to get that positive is to multiply across by a minus 1. If you multiply across by a minus 1, the signs of everything changes. So this becomes y is equal to, was negative, now it's positive, was positive, now it's negative. Now, it may not be obvious yet why we're doing this. And look, you're up on 5 marks at this stage, if not more, okay, because you're on the right path. It's just how far can you get along that path. So I have a statement. Y is this. Now, in equation 2, okay, again, this is a circle. I don't know x or y. But if you think about it, I do know y. Okay, I know it in terms of x, but I do know what it is. So if I swap them out, okay, so instead of y, I'm going to put 2x minus 7. So just take a second to think about that. The x squared is staying the same. The y has been replaced by 2x minus 7. Now, what's the consequence of that? If you look across left to right, this is an equation of the same unknown. So it's an equation of one unknown, so it is solvable. Let's go ahead and solve it. Now, to solve this, I have to do a bit of work. 2x minus 7, let's try to do it down here. 2x minus 7 squared, that means 2x minus 7 multiplied by itself, which is 2x minus 7. Now, there's different ways to deal with this, but this is the multiplication of a bracket of two unknowns by a bracket of two unknowns. Doesn't matter how you do it, you have to make sure that both terms in the first bracket multiply by both terms in the second bracket. I'm going to do it for speed here. I'm just going to track it along. Now, 2x by 2x is the same thing as 4x squared. Now, 2x by negative 7 is the same thing as plus by minus is minus. 2 sevens is 14, and the x carries over. Now, I now need to make sure that minus 7 multiplies by both things. So minus 7 by 2x is also minus 14x. And then minus 7 by minus 7, minus by minus is plus, 7 sevens is 49. Now I can combine these together. Okay, so all I'm going to do now on this next bit is just join the x's. Minus 14x minus 14x is minus 28x. And that's all I've done. Everything else stays the same. The reason I did that was 2x minus 7 squared is the same thing as 4x squared minus 28x plus 49. Doesn't always feel like it is, but they are. Once you realize that fact, okay, you can swap them. So instead of the 2x minus 7 squared, I'm going to put in the 4x squared minus 28x plus 49. That's all I'm doing. Now everything else has to stay. So the x squared here and the 49, they stay, and they're here. Okay. Now once I've done that, I need to try simplify this down. This is still an equation of one unknown, and I'm kind of closer along here, probably at the 10, maybe even the 15. If I go left to right here, I can combine these. These are like terms, so they can combine. 1 of something plus 4 of something is 5 of something. Then over here, minus 28x there's nothing else to join to that, so it stays as minus 28x. Now here, the 49, okay, equals 49. How do I put this? This may be a bit advanced, but ultimately, if you have the same number on both sides of an equation, they can automatically cancel. Now, in a sense, what I'm doing is I'm going, I want rid of that 49. So I'm going to take 49 away from it. Do it to one side, it must do it to both. So what happens? 49 take away 49 cancels. 49 take away 49 cancels. So with any term, if there's the same term on both sides, just get rid of them. You can do that without even thinking. You don't have to show the minus 49. Those two numbers have gone away. And you're left with this statement. Now, this is a quadratic equation. Okay, you could use the minus b formula, but it's probably simpler to factorize this by grouping. So I'm going to look here at these two terms. And I'm looking, is there anything or a different way to express this that's the same? Now, the simplest way we often say is pull out something. Now, 5 and 28 don't look linked in any way whatsoever. You can't divide 5 into 28. But the x, okay, so if I wrote this as pull an x out, if I think of it, if I pull x out of the 5x squared, I'm left with what? I'm left with 5x. In a sense, it's as if, I've run out of space, but 5x squared divided by x, okay, the x cancels one of them, I'm left with 5x. Now, minus 28x, if I can learn to write again, over x, the x's here cancel, you're left with minus 28. Now, the reason I'm doing that is I have two terms multiplying to give 0. And then you can assume, like, the only way you could get 0 as an answer here is if one of these was 0. Or maybe both of them are. So that's why you can say, you can equate them. X is equal to 0, or 5x minus 28 equals 0. Now, x is 0, I can't do much with that, but this 5x take away 28. I can solve this. If I bring the 28 across, okay, actually, let's not do it that way. If I want to get rid of the 28 here, okay, I'm going to add 28 to it. If I do it to one side, I must do it to both. What's going to happen? Well, I'm going to cancel them. I'm left with 5x is equal to 0 plus 28 is the same thing as 28. I'm running out of space, but if I now realize I want x equals my answer, not 5 times x. Simplest way to get rid of the 5 is divided by itself. Do it to one side, do it to both. What's the consequence? Well, they cancel. You're left with x is equal to, I could go decimal here, but shouldn't go decimal unless you have to. 28 over 5 is a number. I couldn't tell you what it is offhand. Now, I know the two values of x. If I refer us back to the diagram, okay, x is equal to 0. That's the x value for that coordinate. X is equal to, now it's 25 over 6 is 64 and 1/6. Is it 25 over 6? Sorry, 28 over 5. What I was thinking of. So 28 divided by 5 is equal to, in decimal, 5.6. Now, does that look like 5.6 if I zoom in? Okay, that's 5, 5.5. So 5.6 will be 3 boxes. It is 5.6. Okay, so I have my x value. I'm now looking for my y value. Now, I've kind of run out of space here. I'll have it here on the next page. I'm just going to use the actual notes here. So again, just to remind what I did, we took our two equations. I took the simpler one, rearranged to find it in terms of one of the unknowns. I chose y, and I got my equation. I then went, well, in my second equation, this y and this, aren't they the same thing? Once I made that realization, I swapped them. Then I did the algebra, and I got my x equal to 0 and x is equal to 28 over 5. Now, to get the y value, I should take either of the two equations. But I don't know what your opinion is. Which of those equations is easier, A or B? To my mind, there's only one answer, and that's A. I've actually rearranged A before back over here. So if I take the rearranged equation, or this one, doesn't matter, this rearrange will just make things easier. And if I put the two values of x I found, okay, so the value of x here, if I put 0 in, I've done it down here, I end up with -7 as the answer by just putting it through the calculator. I do the same thing again for the value of x is equal to 28 over 5. Okay, I substitute it in instead of x. Put through the calculator, I got 21 over 5, which is roughly 4.2, I think it is. So let's go back and see my two values, okay, 0 minus 7, okay, so 0 on the x minus 7 on the y, okay, you see there that's -7. And then the other one here was 5.6 on the x, okay, and was a 4.2 on the y. So that's the x value there, and that's the y value there. So that's the points I got. Now, it didn't ask me to do this in terms of coordinates. We were just asked to show, are we able to apply the the substitution method for solving simultaneous equations? Can we show that we can do that skill? There are lots of parts to it, okay, but remember there's lots of marks. Now, you don't know that's in the exam, but in a question, if you're not sure what you're doing and you can come away with half the marks for that, that's a chunk. Okay, now if you know the skill and can get to the answer, you got to, again, 20 marks, which is a lot of marks. And that should probably be the end of question 4. It is. So look, as before, if you want a copy of the notes I'm working off, just send me an email at shanetry@gmail.com. And if you want a copy of the notes I'm working off, just reach out. And if you like these videos, just click like to subscribe. Get access to more playlists. Thanks.